Hi, welcome to this lesson on the Physics Toolkit, choosing the right unit. Today we are starting with something that looks simple, but is actually very important in physics: units. This lesson is not just about memorizing symbols like kilograms, meters, seconds, or newtons. It is about choosing the right physics tool for the measurement. In physics, the number by itself is not enough. A measurement needs a number and a unit. The number tells us how much. The unit tells us what kind of quantity we are talking about. So today we are going to learn how to choose the correct unit so that our answers actually mean something. By the end of this lesson, you should be able to use the correct units for forces and motion. Some of these units will already feel familiar like kilograms, meters, and seconds. Others may look more complicated, like meters per second squared, newtons per kilogram, newtons meter, and kilograms meters per second. The important thing today is not just to recognize the unit, but to understand what each unit tells us. So as we go through the lesson, keep asking yourself, what does this unit measure? And what kind of physical quantity does this number describe? Let's start with just this number 12. Is 12 big or small? At first, it is actually impossible to answer properly. It depends what the 12 means. If I say 12 kilograms, that could be the mass of a heavy backpack. If I say 12 meters, that could be the length of a classroom. If I say 12 seconds, that could be the time for a short sprint. If I say 12 meters per second, that is the speed of a fast cyclist. If I say 12 newtons, that is a small push or pull. If I say 12 newtons per kilogram, that tells us about gravitational field strength. On Earth, it's about 10 newtons per kilogram, so 12 newtons per kilogram would mean stronger gravity than Earth's. If I say 12 Newton meter, that describes a turning effect, like using a spanner or opening a door. If I say 12 kilograms meters per second, that describes momentum, meaning how much motion an object has. So the same number 12 can mean completely different things depending on the unit. The key idea is this: the number tells us how much. The unit tells us what kind of measurement it is. In physics, a number without a unit is like an answer without a meaning. Now we're going to connect this idea to physical quantities. A physical quantity is something we can measure in physics. For example, mass, distance, time, speed, acceleration, force, moment, and momentum are all physical quantities. A physical quantity should usually be written with a number and a unit. Remember, in physics, a number on its own is meaningless. For example, 180 by itself is not very useful, but 180 meters per second tells us much more. It tells us we are talking about speed or velocity. Sometimes, if the quantity has direction, we also need to include the direction. So when you answer numerical physical questions, remember that the unit gives meaning to the number. Let's begin with the simple units. Simple units measure one basic physical quantity. The four simple units we are focusing on here are kilograms for mass, meters for distance or length, seconds for time, and Newton for force. These are like the basic tools in the physics toolkit. Before we understand the more complicated units, we need to be confident with these simple ones. Now I want you to think like a physicist, choosing the correct tool. For each picture, ask yourself, what are we measuring? If it is a school bag on a scale, we are measuring mass. So the unit in this case would be kilograms. If it is the length of a football pitch, we are measuring distance or length. So the units is meters. If it is the time taken for food to heat in a microwave, we are measuring time. So the unit is seconds. If someone is pulling a trolley, we are measuring a force. So the unit is Newton. Each unit is like a tool. You would not use a stopwatch to measure mass, and you wouldn't use a ruler to measure force. In physics, choosing the right unit is like choosing the right tool. Now we move from simple units to compound units. A compound unit is made by combining simple units. For example, speed is measured in meters per second. That unit combines meters and seconds because speed tells us how much distance is covered every second. Acceleration is measured in meters per second squared. That looks harder, but it means the speed is changing every second. Gravitational field strength is measured in newtons per kilogram. That means the force of gravity on each kilogram of mass. Moment is measured in Newton meters because moment is force multiplied by distance from a pivot. Momentum is measured in kilograms meters per second because momentum combines mass and velocity. The big idea here is this: compound units are clues. If you can read the unit, you can often work out what the quantity is measuring. Now we're going to build units from formulas. This is a really useful skill because it helps you understand where compound units come from. Instead of just memorizing that speed is measured in meters per second, we can build it from the formula. For example, speed equals to distance divided by time. Distance is measured in meters. Time is measured in seconds. So speed is measured in meters per second. Another way to write that would be meters slash seconds or meters per second. Therefore, the unit of speed is measured in meters per second. Pause the video and try this next compound unit. Let's have a look at it together. The formula is acceleration equals to change in velocity divided by time. Velocity is measured in meters per second. Time is measured in seconds. So the acceleration is measured in meters per second divided by time. Now this is a bit more of a tricky one. So let's have a look at it together. So this would be in mathematics, you would have come across something like this. Meters per second can be written like this, divided by seconds. This can also be written as meters per second times 1/second. So from fraction rules, we know that this will just be meters because that's meters times 1, and this is over second squared. But we don't write our units in that format. We tend to write it as meters per second squared. So the unit for acceleration is meters per second squared. Okay, pause the video and try this next example. Okay, let's build the unit for gravitational field strength. The formula tells us that gravitational field strength equals to weight divided by mass. Weight is measured in newtons, mass is measured in kilograms. So gravitational field strength is measured in newtons divided by kilograms. So that can also be written as newtons slash kilograms. Therefore, the unit for gravitational field strength is newtons per kilogram. Pause the video and try this next unit. Okay, for moment, the formula is moment equals to force times perpendicular distance from the pivot. Force is measured in newtons, distance is measured in meters, so moment is measured in newtons times meter, which is written just like this, Newton meter. Therefore, the unit for moment, which is our turning effect of a force, is just Newton meter. Pause the video again and try this next example. Okay, for momentum, the formula is momentum equals to mass times velocity. Mass is measured in kilograms. Velocity is measured in meters per second. So momentum is measured in kilograms times meters per second. Again, we can write this just like kilograms, meters per second. So in the unit of momentum would be kilogram meters per second. Momentum tells us how much motion an object has. A heavy object moving quickly has more momentum than a light object moving slowly. This slide gives us our full unit bank with its description. Let's have a look at it carefully. The first column is giving us the physical quantity. The second column is telling us the corresponding unit. And the third column is describing it, is telling us more about what this physical quantity is doing and what it's measuring. Let's have a look at each one of them. So mass has a unit of kilograms, and this is the amount of matter an object has. Distance of length has a unit of meters, and this tells us how far or how long. Time has a unit of seconds, and this tells us how long something takes. Speed has a unit of meters per second, and this tells us the distance covered each second. Acceleration has the units of meters per second squared, and this tells us how much speed changes each second. Force has a unit of newtons, and it tells us a push or pull. Gravitational field strength has a unit of newtons per kilogram, and it tells us the force of gravity on every 1 kilogram of mass. Moment has a unit of newtons meter, and this tells us that it's a turning effect of a force. And momentum has a unit of kilogram meters per second, and this tells us how much motion an object has. Now we're going to practice choosing the right unit. The question is not just what unit do I remember, the question is what physical quantity is being measured. Have a go at this, try to pick the correct unit for each situation. Pause the video and have a go. Okay, let's look at each of these diagrams. A suitcase on a scale. The correct unit for that would be kilograms. A racetrack length would be meters. A stopwatch would be seconds. A cyclist speed would be meters per second. A rocket speeding up would be meters per second squared. A person pushing a door would have a unit of newtons. Gravity on Earth would have newtons per kilogram. A spanner turning a bolt would have a unit of Newton meter, and a moving bowling ball will have a unit of kilograms meter per second. Now we're going to finish with an exit ticket. Choose the correct physical quantity to its correct unit. Pause the video and attempt this last exercise. Okay, so you should have had the following answers. For kilogram, it's measuring mass. For meters, it's measuring distance or length. For Newton, is measuring force, for Newton meter is measuring moment, for meters per second squared is measuring acceleration, and for Newton per kilogram is measuring gravitational field strength. Okay, great. Great effort so far. The main idea is simple but very powerful. In physics, numbers need units. The number tells us the size of the measurement, but the unit tells us what the measurement actually means. So from now on, whenever you give a physics answer, the unit is not optional. It is part of the answer.